Hello, today we're learning how to solve a system of equations with three variables using the elimination method. So here's my system of three equations over here, and you can see that I've got all three, or I have all three equations in standard form. So this is x, y, z is equal to a constant. So I can easily compare their coefficients. Now, to eliminate, remember we're going to add two equations together, and in order to get something to eliminate when we add them, we have to have their coefficients to be opposites. So we're going to look at the coefficients. We have 3, 2, and 1. None of those are opposites. We have 3, 1, and 2 for the coefficients of y, 6, 3, and negative 1. So none of our coefficients are opposites. But that's okay, because we can multiply one or more than one equations by a scalar to make it happen. So we can manipulate our equations. Now, if I look at x, whenever I have a variable that's just by itself, its coefficient is 1, it's very easy to manipulate 1 to be any number we want. We just multiply it by whatever number we want it to be. So if we're trying to eliminate x, we're going to look at these other two. So let's look at the green one first. So I'm going to write this. So 2x plus y plus 3z is equal to 7. Okay? So now, I want to use this equation, and I need to manipulate the coefficient of x to be something that will be opposite of 2. Well, that's pretty easy. All I need to do is multiply this equation by a scalar of 2. So what I'm going to do is I'm going to rewrite that out here to the side. Well, I'm going to write it down here, and I'm just going to go ahead and multiply that whole equation by 2. So when I do that, multiplying each of the terms by 2. So I have, or I'm sorry, not just 2, but I need it to be negative 2. So I'm multiplying the whole equation by a negative 2. So when I do that, I will have a negative 2x minus 4y, 2y times negative 2. Then negative z times a negative 2 would be a positive 2z is equal to negative 10 times negative 2, which would be a positive 20. And so now when I add these two equations together, let's watch what will happen. The 2x and negative x cancel out. Y plus negative 4y. Well, that's a negative 3y. 3z plus 2z is 5z. 7 plus 20 is 27. So I have an equation with one less variable. But we still can't solve for it because we have one equation with two variables. We need at least two equations when we have two variables. Now, notice I used the green and the red equation here to do this. So I need to use the one equation that I did not use. So I'm going to go ahead and write that out as well. So 3x plus 3y plus 6z is equal to 9. And notice again, I can multiply this x by a negative 3 to get it to be the opposite of this 3x. So if I multiply this whole equation by the scalar of negative 3, I'll have negative 3x, because x times negative 3 is negative 3x. 2y times negative 3 is going to be a negative 6y. Then negative z times negative 3, which would be positive 3z. And a negative 10 times negative 3 is a positive 30. And again, now I'm going to add these two equations together. Again, watch what happens with the x's. They're opposites, so they cancel out. I'm going to add the y's. I get negative 3y plus 9z is equal to 39. So there I have now two equations with two variables, y and z. So I can take these two equations and I'm going to go ahead and just write them down. So I'm going to write this one right here in the middle, so negative 3y plus 5z is equal to 27. But I'm going to do one other thing. Notice when I'm looking at these two equations, I would like to eliminate another variable. So I'm going to use elimination for a second or a third time, because I've used it once here to get this equation, once here to get this equation. I'm going to eliminate the y notice this one would be the easiest to do. So all I need to do, if I keep this the same, this is negative 3y, I want the coefficient of this y to be positive 3y. So what I'm going to do is multiply that whole equation by the scalar of negative 1, and all that does is change the value. So I have, or the sign. So I have 3y minus 9z is equal to a negative 39. And when I add those two equations together, the y's will now cancel out, and I'll be left with negative 4z is equal to negative 12. And now I divide by the coefficient of z, and I get z is equal to 3. So I found one variable. So I've done a lot of work to get there, but now, once I've found one variable, the work gets easier. Now, once I find my first variable, I can plug this value for z into either of these two blue equations, either this one or this one, it doesn't matter, and then I can solve for the other variable in there. So I'm going to plug it into this one, and I'm going to say this negative 3y plus 5, and instead of z, I'm going to replace z with what it is equal to, what its value is, which is 3. And now I only have one variable to solve for again, and I'm going to go ahead and solve for that y. So I get negative 3y plus 5 times 3, which is 15, is equal to 27. I'm going to subtract 15 from both sides. I get negative 3y is equal to 12. And then again divide by the coefficient. And I will get y is equal to a negative 4. There's my second value. But again, we're still not quite done because I need to find 3 variables. So I have a y and a z, but now I need to find an x. So I'm going to go back up to the top. One of my 3 original equations up here. So one of these 3. Let's go ahead and look closer at them. Would it matter which ones we do? Well, no. We have a y and a z. Any one of those three equations will do, but let's look at this one. This one will be the easiest to work with since x has a coefficient of 1. So let's use this red equation. And so I'm going to just go ahead and rewrite that. So we have x plus 2y x plus 2y, and what was it? Minus z is equal to negative 10. So minus z is equal to a negative 10. Okay, so now once I have that written down, I'm free to just replace the y and the z with what their values are that we found. So x plus 2 times y, but instead of y, we're going to be putting in what it is equal to, which is negative 4, minus the z, which is 3, is equal to negative 10. I don't know what that is. Oops. So it's equal to negative 10. There we go. Alright, so now I just solve for the x. So I'm going to get x is equal to 2 times negative 4 is negative 8, minus 3 is equal to a negative 10. Combine like terms, it's going to be negative 11. Now I add 11 to both sides, and I get x is equal to 1. And so there's my third value. Remember, I want to state my solution as a system of 3 coordinates. So x, y, and z in an ordered triplet. So we're going to have x is 1, y is negative 4, and z is 3. And there we have it. Now, if you look at this, notice I've kind of done my work in the shape of an x. So I have shown my problem, my system. I did my 2 steps of initial elimination. I brought it down into the middle and did a third elimination to find my first variable. Once I found my first variable, I plugged it into either of these 2 equations. It didn't matter which ones. And I got this, another variable, a second variable. So once I get my 2 variables, I go back up to my original equations, pick one, plug those into one of these three, and solve for my third variable and state the solution. Hope you enjoyed this. Thanks for watching. Have a great day.